All right, what we're going to do now is solve radical inequalities. And you'll notice that the steps to solving these are going to be very similar to what you did for equations. We will have one additional thing we'll have to think about, but you still need to isolate the radical, and that's what we're going to do first. Isolate the radical sign. So I'm going to add 4 to both sides. And when I do, I get the square root of 2x plus 3 less than or equal to 9. Then my next step, just like with equations, was to square both sides. So I'm going to square both sides. And I get, remember when you square a square root, it cancels out. They are inverse operations. So I get 2x plus 3 is less than or equal to 81. Now I'm just solving an equation. Subtract 3 from both sides. Gives me 2x is less than or equal to 78. And divide both sides by 2. Gives me x is less than or equal to 39. Okay? So we get an answer, x less than or equal to 39. Now there's one additional thing we have to think about. And remember that the radicand, that's the part that's underneath the square root. So the radicand can't be negative. So that means that 2x plus 3 has to be greater than or equal to 0. And so that's an additional condition I have to think about. So I'm going to solve this. So subtract 3 from both sides and then divide by 2. So I get that x has to be greater than or equal to negative 3/2. Now we said that the solution was x is less than or equal to 39. What this does is this just gives me a restriction on my solution, and it's really giving me a lower limit. I can't go below negative 3/2. So if I were to think of this on a number line, and here's 39, so it would be 39 or less, which would be this way on the number line. However, there's a lower limit. I can't go below negative 3/2. So that would be my lower limit. So this would be my solution on a number line. I can include negative 3/2. So if I were to write out my solution, I can write negative 3/2 less than or equal to x less than or equal to 39. Now, sometimes the restriction won't change your solution, or it won't offer a higher or lower limit, and you'll see some examples of that. But you do have to take that into consideration when you are solving radical inequalities. Now I've listed this one for you to try, so you might want to pause this and see if you can work this one out. First thing I'm going to do is isolate the radical, so I'm going to add 2 to both sides, and I get the square root of 9 minus 5x greater than or equal to 8. Then I can square both sides. And when I do, I get 9 minus 5x is greater than or equal to 64. Let me show this in case. So I was squaring this side. Remember, when you square a square root, they cancel out. Now I'm going to subtract 9. We get negative 5x greater than or equal to 55. And my last step is to divide by negative 5. But you do need to remember to flip the inequality when you divide by a negative. So this is going to flip. So we get x is less than or equal to negative 11. And that's my solution. So now I have to see, is there an extra restriction on my solution? So to do that, I have to take my radicand, 9 minus 5x, and this has to be greater than or equal to 0, because remember, it can't be negative. So I'm going to subtract 9 on both sides, and we get negative 5x is greater than or equal to negative 9. And then I have to divide each side by negative 5. And I'm going to flip this when I do that, so I get x is less than or equal to 9/5. So now let's think about our solution. Here's negative 11, and my solution is less than or equal to negative 11. Now think about where 9/5 is. Well, 9/5 is up here somewhere. And my solution has to be less than 9/5. Well, it already is, because it's less than or equal to negative 11. So this does not add, it's the opposite direction. So this does not put a limit on my solution at all. It doesn't add to my restriction. So my answer is just x is less than or equal to negative 11. We still have to check this because sometimes it matters. This was a case where it doesn't. If this had been greater than a particular value, if it was especially, it would have to be below negative 11, then that would have added a restriction. But in this case, it does not. All right, now this one might look a little different to you. Remember what a 1/3 power means. If you raise something to the 1/3, like x to the 1/3 power, remember that tells you it's a cube root. So this is just the cube root of something. So if you want to undo a cube root, think about what you would do to undo cube root. You're going to cube both sides. And that's going to be our strategy here. So let's take a look. First, we want to isolate that expression. So I'm going to subtract 3 from both sides. And I get 6n minus 5 to the 1/3 power equals negative 5. And you can put it as a radical if you want to, but to undo cube root, you cube both sides. So let's just think about cubing this. A power to a power, you multiply the exponents. Well, 1/3 times 3 is 1. So you get 6n minus 5. And you can evaluate this, negative 5 times negative 5 times negative 5. You can use your calculator if you need to, or if you know that's negative 125. All right, so again, all I did, power to a power, I multiplied and I got 3/3, which is 1. And you're always going to, if this is a 1/3, you'd raise it to the 3rd power. If this was a 1/2, then you'd square it. If this was a 1/4, then you'd raise it to the 4th power. So you're always going to do the inverse operation. So once we have it to this point, it's easy because we're just going to add 5 to both sides. We get 6n equals negative 120. By the way, I'd switched to an equation. This was an equation, not an inequality. So we don't have that additional situation we'll have to look at. And then divide each side by 6. I get n equals negative 20. So that's my answer I get. Now I should double check it. And if you substitute in a negative 20, you'll get negative 125 and the cube root of that. Now it's okay to have a negative if you have an odd root, because you can do a cube root of negative 125. So that's okay. This can't be an even root because then we would have a non-real solution. But it's okay to have a negative in the radicand as long as this is an odd root, in which case this is. And so this solution will work. Here's the last problem, and you can go ahead and try this, and then I'm going to, I'll show you how to do it. All right, so I'm going to start by subtracting 4 on each side, and I get negative 7 minus y to the 1/2 power equals -4. Now this negative is a problem. I really don't want it there. So I'm going to multiply both sides by a -1. So when I do that, that cancels out the negative, and I'm left with 7 minus y. If you want to, you can put this as a square root because it was a 1/2 power. All right, so when you have a 1/2 power, if you want to put it as a square root, that's fine. Then I'm going to square both sides. And when I do that, I get 7 minus y equals 16. Remember, when you square a square root, it cancels that out. Then I'm going to subtract 7 from both sides. We have -y, or the opposite of y, equals 9, which means if you multiply both sides by -1, you get y equals -9. Let's double check our answer. If I check that, I'm going to have 4 minus 7 minus -9 to the 1/2 power. So you got to be really careful. This was a minus, but my y value was also negative. So I have to do it like this, which means this changes to adding the opposite. So we get 4 minus 16 to the 1/2 power. 16 to the 1/2 power, remember that's the square root of 16, which is 4, and 4 minus 4 is 0, and that's what we were supposed to get, which means it works. All right?